So you've definitely heard of Schrödinger's cat, right? This famous thought experiment about a cat that's somehow dead and alive at the very same time. It's probably one of the most mind-bending ideas in all of science. But here's the thing. What if the story we all think we know is actually completely backward?
I mean, that's the big question, isn't it? A cat, both dead and alive? It just sounds impossible. It's the ultimate quantum paradox. But was that really the point? Was Schrödinger trying to tell us that this is how the world works? Well, let's dig in and find out.
All right, so before we totally blow your mind with the real story, let's just do a super quick run-through of the popular version. You know, the one that made this cat a legend. Okay, the setup is pretty grim, not gonna lie. You've got a cat, and it's sealed in this steel box. Now, its fate, its very life, is tied to a single radioactive atom. If that atom decays, which is a totally random quantum event, a hammer gets triggered, it smashes a flask of poison, and, well, you know. But if the atom doesn't decay, the cat is perfectly fine.
And this is where things get super weird. According to the rules of quantum mechanics, until you actually look, until you measure it, that atom is in a state of both decayed and not decayed at the same time. It's called superposition. So if the atom is in this blurry in-between state and the cat's life is directly linked to it, well, then the cat must also be in a state of being both dead and alive. Crazy, right?
Okay, stop right there. That's the story everyone tells. But what if I told you that entire conclusion, that famous dead and alive cat, is the complete opposite of what Schrödinger was actually trying to say?
And that brings us to the real story. See, Erwin Schrödinger wasn't trying to be a champion for quantum weirdness. Not at all. He was actually trying to point out that one of the leading ideas about it had gone off the rails and become totally, completely absurd.
And you don't have to take my word for it. Look at what he himself wrote back in 1935. He said you could set up quite ridiculous cases. He wasn't saying, hey, look at this cool quantum feature. No, he was using the cat as an example of something utterly ridiculous to prove a much bigger point.
So here's the big mix-up in a nutshell. The pop science myth is that the cat proves how weird and wonderful quantum mechanics is. But Schrödinger's actual point was the total opposite. He was basically saying, hey, look at this ridiculous conclusion my cat experiment gives us. A cat can't be dead and alive. That's absurd. So maybe, just maybe, the theory that leads to this absurdity has a problem when you scale it up from atoms to, cats.
He even said that this whole mess prevents us from so naively accepting as valid a blurred model for representing reality. His point was that the theory was describing reality itself as being fundamentally blurry or fuzzy. But Schrödinger thought, no, reality is sharp and clear. It's our knowledge of it that's blurry. The theory was confusing the map for the territory.
And this wasn't just some abstract academic game for him. Make no mistake, Schrödinger was firing a major shot in a huge scientific war over the very nature of reality itself.
His main target? Something called the Copenhagen interpretation. This was the dominant idea back then. It says that a quantum system, like our atom, exists in all of its possible states at once. That's the superposition thing we mentioned. But the second you observe it, this cloud of possibilities collapses and it's forced to pick just one reality. For Schrödinger, this idea that reality just kind of waits around for us to look at it before making up its mind, that was just too much to swallow. And you know what? He wasn't the only one who felt that way. His good friend, some guy named Albert Einstein, totally agreed with him. In fact, Einstein wrote him a letter saying he loved the cat paradox because it showed just how silly this whole observation creates reality idea was. For them, it was simple. The cat is either dead or it's alive, period. Our looking at it doesn't change a thing.
But this whole debate was actually a good thing. It kicked off a ton of other cool ideas. You've got the many worlds interpretation, which suggests that maybe the universe just splits. In one universe, the cat lives. In another, it dies. Then there are hidden variables theories, which say maybe it's not random at all. We just don't have all the information. And another big one is decoherence, which argues that you don't need a person to observe the cat. The environment itself, the air in the box itself, is constantly measuring it, forcing it to be one or the other long before we ever peek inside.
So let's recap. Schrödinger created this whole thing to be a dead end, right? An absurd example to show a theory was flawed. But, and this is the really ironic part, his ridiculous idea has actually become the foundation for some seriously futuristic technology.
Because it turns out that this concept, a system being in two states at the same time, the very thing that's impossible for a cat, is an unbelievably powerful tool when you can control it at the quantum level.
So powerful, in fact, that scientists literally named a key concept in quantum computing after it. It's called a cat state. And it's basically when you get a bunch of quantum bits or qubits all linked together in a superposition of two opposite states. Think of them being all zeros and all ones at the exact same time. This is the secret sauce that gives quantum computers their incredible power.
And how far have we taken this idea? Well, the latest record is pretty impressive. It's 20. That's right, researchers have actually created a cat state that links a record-breaking 20 quantum bits together. This is the absolute cutting edge. They are building real-world tech based on the very idea Schrödinger thought was a joke. His punchline has become their blueprint.
Which brings us right back to the biggest mystery of all. We can make a cat state with 20 atoms, but we can't do it with a real cat made of trillions of atoms. So where's the line? At what point do the bizarre rules of the quantum world give way to the normal everyday physics we're all used to? Schrödinger asked that fundamental question almost 100 years ago with his cat, and amazingly, it's a question we're still trying to answer today.